Hello, geometry folks. This is Mr. Heron back with you, and I'm hoping you're ready for the back half of Unit 3. This part's a little bit tougher. You've got to make some logical arguments here, mixed in with math. But before we get into that, I want to go through just this example for you, and it stems from this idea that if I've got a triangle, but then I've got an exterior angle, so like this. It stems from this idea that, A plus B is going to be equal to X. Okay, that's kind of this idea. So I want you to notice something. This, although it looks 90, it might not necessarily be 90. What I'm trying to get you to look at is the fact that these two together equal this. So it's just X plus 42 equals 3X minus 102. Then a few algebraic steps. 0, 0. So that is going to be 154, and that will be 2x divided by 2. That becomes 1. 154 divided by 2 will be, let's see, that will be 7, 7, done. So x will be 77. But this is an idea that a lot of students forget, so I want you to remember. These two, the remote interior angles are equal to the exterior angle. This should actually be 3.4, not 3.3. It's 3.4. That's been a 4 the whole time. You saw nothing. Talking about proving triangles congruent. And proving triangles congruent is exactly what it sounds like. You're trying two triangles and see if they are congruent to each other. Now, the idea is using what's called a postulate or theorem, and for our purposes, you won't need to know that difference. It's more of a postulate is just going to describe a fundamental relationship in geometry, and they're just accepted to be true without proof. Okay, they just assume to be true. A theorem can be proven true using terms, definitions, postulates, and things like that. So a postulate or a theorem, it's for all intents and purposes, it's something in geometry that we assume to be true. A theorem can be proven, a postulate cannot. I'm sorry, we have side congruence. This is our first way to determine if our triangles are congruent. So if I look, AB is congruent to DE. BC is congruent to EF. And CA is congruent to FD. If this is the case, 3 sets of sides, then triangle ABC is congruent to triangle DEF. Also notice the corresponding points are lined up. That needs to happen, okay? You need to do that. So let's look. So this is our first way to decide if triangles are congruent, okay? So we've got side angle, side congruence. Second one is if you have the included angle, okay? The included angle for side angle, side. Okay, so please note, this angle, it's in between the two sides of the triangle. Okay, it's in between the two sides that you know. So for here, I'm proving or I'm showing that AB is congruent to DE. I'm proving or I'm showing or I'm given that B is congruent to E. I'm showing that BC is going to be equal to EF. So ABC going to be congruent to DEF by side angle, side. So now this is going to be with the included angle. Okay, that needs to be heavily emphasized. So now angle, side angle, just kind of a flip around. So instead of two sides and an angle, now I've got two angles and a side. All right, so angle B matches up to angle E. I've got AB matches up to DE. And I've got angle A matches up to D. So now notice, it's two angles, or two pairs of angles, and the side included. Okay, so I can't have this side, that doesn't work. I can't have this side, that doesn't work, okay? It's got to be the included side for angle, side, angle. So again, I can say ABC, DEF by ASA. There's your answer. But you have to look for the relationship between the two. Okay, this one is probably one of the tougher ones to notice. And the way I think about it is, as you're going around the triangle, what's it look like? So if you're going angle, angle, side, you're going angle, angle, next side. Angle, angle, next side. That's kind of the way it goes. So if I say A and D, B and E, and that next side of B, C, and EF, that's how you do angle, angle, side. Okay, that's how you do angle, angle, side. And angle, angle, side is the last one that we're going to talk about. Okay, so you have angle, angle, side. So 4 ways, all the sides, 2 sides with the included angle, 2 angles with the included side, or 2 angles with the next side. So you go A, B, next side, D, E, next side. All right, so those are your 4 ways. So now this one, pretty straightforward. I've got side here, side here, side here, side here, side here, and side here. So I've got all sides, no angles. I've got 3, so that makes it the side, side, side. This one ends up being a postulate. Okay, so you can just put SSS or side, side. So here, we'll take a look. They tell me those 2 are congruent. I can also say that since this is part of both triangles, I can say that you're congruent to that it's congruent to itself. It's the same side, so it's congruent. So I have 2 sides, no angles. That is not enough to tell me that the triangles are congruent, so no congruence can be proven. So now let's take a look here. So let's see. This one, I have 2 sides. This one and this one. And I've got 1 angle, but it's not the included angle. So there's no side angle. That wasn't one of our options. So this one cannot be proven. That one can't be proven. Over here, letter D, KM bisects JML. Bisects literally means cut in half. All right, so bisects JML, that means this angle is congruent and this angle is congruent. And now if you notice, MK is part of both triangles, so that's equal. So I can say JMK congruent to triangle LMK, and that's going to be angle, angle, side. So if you notice, you have angle, angle, next side, angle, angle, next side. That's my answer. Okay. Again, this one's a tricky one. So now let's play around a little bit. You're given that they're congruent to each other. Let's see what we can figure out for X. So let's see here. Let's see, BC, oops, I want that one, I want this one. BC right here matches up to WX, so that's over here. So I'm going to get 2X plus 5 equals 11. So a couple algebraic steps later, I get x is 3. And since it doesn't really ask me what to do, oh, find the value of x. Oh, I did that. Bam, we're done. Moving on, nice and easy. I figured out that these two were corresponding, matched them up, lined them up, and away I go. Don't worry about that one. This one I wanted you to notice because this is just a specific example. This side, this is part of both triangles. So these two triangles would actually be side, side, side. This one, see, this is part of both triangles. This one's actually going to be angle, angle, side, angle, angle, side. So that one's actually going to be AAS. This one, nothing. You only have one side, one angle. That's not enough information to make a distinction one way or the other, no matter what it looks like. This one, again, this is part of both triangles. Technically, I mean, there is one called a hypotenuse leg, but it's very, very specific. Hypotenuse leg, this is only in right triangles can you use this one. We don't talk about it. It doesn't really show up anywhere, but there is one called hypotenuse leg, and this would be your hypotenuse because that's your longest side of a right triangle, and that's one leg. So that one technically would be yes, but we don't talk about it. Here, you know, I can figure out that those two are vertical, so that's 3 angles, but that's not enough to tell me that they're congruent, so no. Here, so this is part of both triangles, so I can say yes. This one's actually going to be angle, side, angle, because I've got angle, the included side, angle on both. Okay. I know I went through a whole bunch of these. This one is one that likes to trip kids up. A lot of kids would say yes, but look at what this actually says. This says these two are equal. This says these two are equal. There's nothing over here to say that they're equal to over here. Okay, I can say, yeah, I can say these two angles are vertical, but these two sides over here are congruent, and these two sides over here are congruent. So literally, really, I've only got one angle that's congruent between the two of them, and that's not enough. That's not enough. So I'm going to say no, that's going to be not enough information. Okay, went through a couple of examples with you. Please take your time, make sure that you're able to recognize, that's the biggest piece, being able to recognize all these things, all these situations, and being able to definitively tell me yes or no.